here we are looking at the gradient of the sine curve. Now, differentiation also tells us about gradients. So if we can plot out the gradient of the sine curve, it might give us an insight into what sine differentiates to. Now, let's have a look at some of the key features of the sine curve. At 90 degrees, it goes completely flat, and the same happens at 270. If you were to draw a tangent at these points, they would be completely flat, like so. So when I'm thinking about the gradient of sine x, I'm just going to put that here, 90 and 270. Now, I'm also going to look at the steep parts of the graph. They happen in between the flat bits. So we have a particularly steep bit here at 180. That looks to be the steepest section, and this is a negative gradient, it's going downwards. So I'm going to pop a point down here, 180, steepest negative. And the steepest positive points in the graph seem to happen at 0 and at 360. So let's mark that on. Okay, so the sine curve is fairly smooth, so I'm going to try and follow that smoothness, and we'll see how this goes. This could go disastrously. Could be worse. So we get that sort of shape, and you might recognize this. It very much resembles the cos curve. And when we get a little bit further into the second year of the course, we'll look at something called radians, and if the angle is being measured in radians, sine will differentiate to cos, which is great. I've got the actual cos curve just below. That's what it's supposed to look like. I think that's okay. Yeah, that's not too bad. Yeah, we'll take it. So the key thing to take away from this, something that we're going to use in the differentiation module, is that if I differentiate sine, I should get cos. We can also do a similar sort of thing with the cos graph. So if we look at the steepest parts of the cos graph and where the cos curve goes flat, we can get an insight into what cos might differentiate to. Let's have a look at the flat parts of the graph first. So cos goes flat here, right at the start at 0 degrees. Over here at 180, and up here at 360. So on my gradient graph, I'm going to mark that as flat. So it's going to be on the axes once, twice, 3 times. When I'm looking at the steep parts of the graph, the steepest positive part of the graph, this is all negative, is over here. So this is gradually getting steeper and steeper. This is the steepest bit, and then it levels off again and gets flatter. The steepest positive section is at 270. And the steepest negative bit is at 90. And I'm going to join this up. Oh, that's a bit dodgy. Oh well. Okay, so this does still resemble the sine graph, but it's upside down. So if we're looking at the gradient of the cos graph, and we're differentiating cos, we should get minus sine out. And later on in the year, we'll prove that more rigorously using first principles, but it's just to get the intuition for now. So what have we learned here? if we start with sine x and we differentiate that, we should get cos x. And if we differentiate that, we'll get minus sine x. Now this will go full cycle. So if I differentiate minus sine, I should get minus cos. And if I differentiate minus cos, that should take me back to sine. And we get that repeated process.